Chromosomes can be altered in their number or structure. Aneuploidy, which is where you either have an extra chromosome or one less chromosome, is one such term used to describe these alternate numbers. If you look here, you got a 2n plus 1. That 2n plus 1 indicates you still have the diploid number of chromosomes, so you still have two sets of all the chromosomes, except for one of the sets has an additional chromosome, and that's why the plus 1. And that would be called a trisomy because they have 3 of one of the chromosomes. If you look over here, you got a 2n minus 1, so that one's still a diploid cells, except for one of the chromosomes is missing one, and so we call that a monosomy. And those are caused by a non-disjunction. So if you remember back when we did meiosis, a non-disjunction occurs during either anaphase 1 or anaphase 2 of meiosis. And remember that's so in anaphase 1, it's the homologous pairs that are separating, and in anaphase 2, it's the sister chromatids that are separating. Sometimes they fail to separate, and so if they do, you could end up with an extra chromosome, or you could end up with one less chromosome. Sometimes you have what's called polyploidy, which is where you might have 3 or more of each type of chromosome. And that would just mean that instead of being a diploid cell, you've got, instead of 2 sets of each, you'd have 3 sets of each chromosome. And you can see that down here in this karyotype, and a karyotype is just a map of all of the chromosomes of that individual. But if you look at this, you can see each one has 3 chromosomes. And even on the sex chromosome down here, you've got X and then 2 Y chromosomes right here. So there's 3 of everything, and that would be an example of a polyploidy. And those are caused by either where the sperm fails to go through non-disjunction for all of them, so it ends up being a diploid sperm, whereas typically sperm, remember, is a haploid cell, or you could have fertilization of the egg by 2 sperm, and so then that ends up with having 3 copies of each. Right here is an example of a monosomy. So this right here is something called Turner's syndrome, and you'll notice there's 2 of each chromosome, with the exception down here there's just one X chromosome, so it's missing the second sex chromosome, and therefore it's a monosomy because it would be a 2n minus 1. And this is just kind of a little recap to remind you of how non-disjunction can occur. So here's your first meiotic division in this one right here. So if you look, you've got meiosis 1, where you've got the 2 chromosomes doubled, and then in meiosis, when it completes meiosis 1, you've got 1 in each, and then over here, this is normal, you end up with 1 copy in each one of these. So there's just 1 chromatid in each of the 4 cells. If a non-disjunction occurs in meiosis 1, notice here you've got 2 chromosomes, and over here you've got none. So typically these homologous pairs should have separated, and 1 should have been in each cell, but they didn't. And so you end up here at the end, when you get all done with meiosis 2, you end up here with 2 chromatids in each cell, and over here you end up with none. If the non-disjunction occurs during meiosis 2, so here in meiosis 1, this is still normal in meiosis 1, and then when it goes through, this one right here would be normal in the first 2 cells. So after meiosis 2, these are normal, but here these sister chromatids fail to separate, and so you ended up with this cell having 1 and then this cell right here having none. So those would be called non-disjunctions. Now let's look at a couple of examples of autosomal chromosome alterations. And remember, the autosome is any of the 22 pairs of chromosomes that are not the sex chromosome. Probably the most common one is trisomy 21. You most likely know it as Down syndrome, and you can see that it affects both female and male, and it's caused by an extra 21st chromosome. So if you look down here at the karyotype, which remembers a map of all the chromosomes, you can see that this individual has 3 21st chromosomes. That can cause intellectual and developmental problems for the child. Can be mild symptoms all the way up to more moderate level. And it's caused by a non-disjunction of that chromosome 21. And as we saw in the previous slide, it occurs either during anaphase 1 of meiosis or anaphase 2 of meiosis, where those fail to separate. The risk of it occurring increases with a woman's age, usually 35 years and older. There's a greater risk, and it gradually grows the older the woman gets, the greater the risk of having a baby that has Down syndrome. A couple other ones that are here that you can see are trisomy 18, which is Edwards syndrome. You can see that in the karyotype here. This individual has 3 chromosome 18s, and it's caused by, that extra one there as well. So you'll notice that they've made the individual have 47 chromosomes instead. Usually it causes death to the baby before birth or within the first month. Only about 5 to 10% of all cases live past their first year. They usually have low birth weights, heart defects, and other intellectual disabilities. Trisomy 13 is another one that causes Patau syndrome. And you can see again they have 47 chromosomes, but this one would have 3 13th chromosomes. It causes severe intellectual disability, heart defects, brain spinal cord abnormalities, poorly developed eyes. Sometimes they even have extra fingers or toes, a cleft lip. But again, most die a few days to a week and after birth, and only 5 to 10% live past that first year. Now we'll look at a couple of alterations in the sex chromosomes. First one listed there is an individual that has XYY, which is known as double Y syndrome or Jacobs syndrome. You'll notice that they have 3 sex chromosomes, 2 Ys instead of the typical 1. And they would phenotypically appear normal if you looked at them. They would just be taller than the average male. The next one that's listed there is XXY, and you can see that's shown in the karyotype down below here. They have 2 X chromosomes and then 1 Y. Usually they are taller males, they're sterile or almost sterile, and they have more feminine characteristics such as sparse facial hair, somewhat enlarged breasts, and in order to help them be more male characteristics, they are treated with testosterone. If you remember back when we studied Barr bodies in the genetics chapter, earlier part of this genetics chapter, you'll remember that the Barr bodies where the X chromosome in one of the X chromosomes in the cell has been inactivated and it shows up on the side of the nucleus, and so they use that for the Olympics, remember, to determine if they were male or females. This individual, even though it is considered male XXY, based on those tests, that individual would not fall under the guidelines of male. They would be considered females because they had that Barr body. Here are a couple more ones that affect the sex chromosomes. There's XXX, which has an extra X chromosome called trisomy X syndrome or poly-X syndrome. Most of these would develop normally. You'd never know, phenotypically looking at them, that they had any issues. The other opposite scenario, so this one would be an extra chromosome. This one is missing one with the Turner syndrome. They are X0, and they are phenotypically a shorter individual. They're infertile generally, they're smaller breasts, considered female. They are usually given hormone treatment because many of them would not undergo puberty without that hormone treatment. So they would typically have that. Again, this would be one of those individuals that would look like they were not female, because if they only have one X chromosome, they wouldn't have the Barr body. So this person, even though they have the characteristics of a female, they would be considered male based on those same Olympic guidelines. So they would be considered a male instead and wouldn't be able to compete as a female. So you can see where that Barr body test is not a very reliable test. This chart here shows some of the common changes in chromosome number and how often they actually occur. And you can see here that for trisomy 21, which remember is Down syndrome, 1 in 1,000 births, live births, would have that particular condition. That's the most common of them all. And then you can see that XYY, XXY, and XXX are all 1 out of every 2,000 births. And the least common one is that Turner syndrome, where they only have the one X chromosome. That occurs 1 in 10,000 live births.